Right, this is where we left off yesterday, correct?
A little bit past this.
So, I'm sorry?
A little bit past this.
A little bit past this?
Yes.
We're kind of down with, maybe down there with that stuff, right? I think.
Yeah.
Yeah, we're talking about the sets of real numbers, right? What did we say about that? We said all real numbers are either rational or irrational, one or the other. Remind me, what was maybe our simplest definition of a rational number? A number that can be written as a fraction. Good. Okay, fraction of integers. Good. So then, what are irrational numbers?
Numbers that can't be written as a fraction.
Good. Numbers that cannot be written as fractions of integers. We said that, and we talked about subset. This is where we left off. We said, okay, if we take the rational numbers, we can break those up into, there are some smaller sets of rational numbers inside the set of rational numbers that are interesting to us. And the one that I think we left off talking about integers, right? Is that right?
Yeah.
Okay. And we said integers, if I remember right, and you correct me if I'm wrong here. We said integers, we talked about them as being, let's get earbuds away, please. Integers are the hash marks on a number line. It's one way to think about them, right? Rational numbers are fractions. Well, integers, another way of thinking about it would be to say integers are the simplest possible fractions. They're the fractions whose denominators are 1 when I reduce the fractions, right? Okay, give me thumbs on that. Is that all ringing a bell? Making sense?
Yeah.
Good, okay. Good, so then and I put stars by the stuff that's important to you on the homework and the test. So we need to know these three sets, real numbers, rational numbers, irrational numbers, and we need to know integers. And then we talked about this set builder notation yesterday, right? A little bit, right? This way of saying stuff like the set of all x such that x corresponds to a point on the number line. Did we go through that a little bit? Give me thumbs. That makes sense. Okay, good. Okay. And we'll continue with that today. So some other sets that we're not going to worry as much about, but I just want you to at least be familiar with them. I won't put them on the homework. They won't show up on the test. But a smaller subset still, a set that's inside the set of integers, we could get, if we broke the set of integers up into kind of pieces. The integers consist of the positive integers, 1, 2, 3, 4, etc., all the way up to infinity. The negative integers, -1, -2, -3, all the way down to negative infinity. And then the middleman, 0, which is in the middle, between the two, right? Well, what if we exclude the negative integers? If we only keep 0 and the positive integers? That would be a part of the set of integers, and we give it a name. We call that the set of whole numbers. Okay. So whole numbers would be all the integers except the negatives. This is, by the way, this is a different way. I think I probably mentioned this yesterday, but if I didn't, we'll talk about it today. Here's another way of writing a set. This is a little less complicated. I didn't write this using set builder notation. I just used plain old set notation, where I've got these script brackets that tell us we've got a set, a collection of stuff. Think what a set means. Like if you've got I don't know, like what would be a set you'd have? A set of dumbbells. Yeah, a set of dumbbells. What's it mean to have a set of dumbbells? You got just a bunch of dumbbells probably sitting on a rack. They are a collection of dumbbells. They're all, each dumbbell is going to be a part of the set of dumbbells, right? A set is just a collection of things, right? So anytime we talk about a set, it's a collection. Well, here's a collection of whole numbers, right? If I use set notation, inside the set brackets, I'm just going to list every element of that set, every member of that set, separated by commas. Well, the set of whole numbers just starts at 0. That's the lowest value, the smallest value, and then increases by 1 forever. And did we talk about this ellipsis yesterday? A little bit? Did I say that word? Okay.
It goes to infinity.
Meaning it goes forever, right? So we're just going to use this trend. So 0, 1, 2, 3, and that ... means etc. It's forever, right? So there's the set of whole numbers. If I exclude 0, so I start at 1 instead of 0, that's an even smaller set. That's a set that's inside the set of whole numbers that we call the set of natural numbers. And that's everything. That's all the sets we would ever talk about this year. Okay? All right, and then just for your notes, I just put some other stuff in here. Reminded you what an ellipsis is and what it means. This is called set notation, this simpler way of writing sets. Okay? And then I just want to compare the two. So now we've got two different ways of writing sets. We can use set builder notation, or we can just use a simpler form of set notation. So these two sets are exactly the same. We're just writing them in different ways. We're naming them in different ways. This would be the simplest way. If I have a set 1, 2, there's only two elements in that set, the number 1 and the number 2. And the easiest way to write the set would just be to use set notation with a 1 and a 2 separated by a comma. Another way of doing that seems a little bit too complicated, unnecessarily complicated, would be this way. I could say something like, I could say that same set by saying the set of all x such that x is a natural number less than 3 would be an alternate way maybe of saying that. Think about that. If I look at the set of natural numbers, there it is. What are the only natural numbers less than 3? 2 and 1, right? So that's another way of saying the set of 1 and 2 would be the set of all natural numbers less than 3, right? I don't know about you, but I would choose that way, don't you think? Seems a little simpler. Okay. What do we do with a set that contains no elements? Because sometimes that can happen. We can have a set with nothing in it. We call that the empty set, or sometimes people call it the null set. We'll just call it the empty set. How about? And how do we represent that? Well, one way we could do it is we would use this set notation, only there's nothing inside. There are no elements. So it would just be set brackets with nothing inside of them. That's one way of saying the empty set. We could also use this symbol. It looks like a circle with a slash through it. That also means the empty set. Okay, both mean the same thing. Here's an example of a set that is the empty set. The set of all x such that x is a month with 32 days. Think about the calendar. How many months are there with 32 days? None, right? So that is equal to the empty set. There aren't any, okay? Okay, another symbol that I just want to introduce you to. This kind of like a sideways, sort of looks like a pitchfork E. Think of it like an E because the meaning of that symbol, it means is an element of, right? So here's a true statement. 3 is an element of. Remember, element is our fancy word, just means a piece of a set. An individual piece of a set we call an element. 3 is an element of this set, and we can see that it is because there's a 3 in the set, right? So that's a true statement. 3 is an element of this set. Here's the way we could use that new symbol. It says the same thing. That's what that means. 3 is an element of that set. Anytime I put a slash through a symbol, it just adds the word not. So this is also a true statement. P is not an element of this set. How come?
Because it isn't in there.
It's not in there, right? There's no P in that set, so that's a true statement. Okay? How about this one? List for me, we're going to write this using set notation. I want you to write the set out using set notation, listing all the elements. The set of all x such that x is an integer less than or equal to 1. Okay, think about that. I want all the integers less than or equal to 1. Okay, so does that set have a biggest value? 1. What do you think, everybody? Give me thumbs on that. Is there a biggest value in that set? There is, isn't there? What is it? 1. Okay. So if I wanted to write this using set notation, we can start off, I'd do something like that. On the right edge of because I always want to write the elements in increasing order in a set. So the biggest value would be 1. What would be the next one down? Then what? -1, -2, -3. Well, how long do I have to go? Forever, so I can't do that. What do I do instead? Dot, 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 and do that ellipsis, right? So it looks something like that. I didn't even really need that many pieces in there. All I need is enough elements to just establish the trend. So maybe like 2 or 3 would have been enough, okay? Okay, last symbol is really similar to this symbol, right? Remember, this one meant is an element of. This symbol means is contained in, and there's a really small difference. If I were going to say, like, let's look at this statement right here. We're going to say capital N is the set of natural numbers. How many elements are there in the set of natural numbers? If we go back, what would that look like? Set of natural numbers.
Natural numbers are 1, 2, 3.
Yeah, starting at 1 and going to infinity. So how many pieces are there in that?
1,
How many total elements are there?
Infinite.
Infinite, right? It's an infinite number of things. The set of integers we're going to call Z. Infinite number of pieces, elements in the set of integers, right? So it wouldn't make sense for me to ask the question, is N an element of Z? Is the set of natural numbers an element of the set of integers? Element wouldn't make sense there, because if I'm asking if something is an element of a set, that implies, is it a single piece, right? So it's true to say that 3 is an element of this set because 3 is an individual piece of that set, right? But I can't use that terminology or that symbol when I'm talking about a set inside of another set, right? Then I have to use this one instead. It replaces it. This means is contained in. So this would make sense. Well, you tell me, is this true or false? Is the set of natural numbers, even though it's infinite, is that contained in the set of integers?
yes.
It is, right? Because it's inside the set of integers. So that's true. But again, the reason I had to use that new symbol is because I'm talking about more than one thing that's contained in something else. So I have to say it's contained in. Okay? Make sense? All right. And then here's just a little summary of all the stuff we talked about with our number sets. Real numbers are broken into irrational numbers and rational numbers. And then rational numbers, inside rational numbers is the set of integers. Inside that's the set of whole numbers. Inside that's the set of natural numbers, right? Thank you. Okay? One last little piece on this though. What if we want to write numbers as decimals? Okay? If I write a rational number as a decimal, there's only 2 things that could happen. Let's take 2 examples to illustrate this. Give me thumbs. Is 1/4 a rational number? Thumbs up or down? Rational numbers are all the numbers that can be written as fractions. Is 1/4 a legit fraction? Yeah, it is, right? So everybody agree 1/4 is a rational number, okay? If I write 1/4 as a decimal, what do I get? 0.25, 0.25, okay? Do I need any more decimal places, or is that it? That's it, right? 0.25 is exactly 1/4. Anybody know what we call a decimal like that just stops? It doesn't need to go any further. It starts with a T. It starts with a T-E, T-E-R.
Tertiary.
No. Terminating. You ever heard that word before? Terminating decimal? Oh, maybe not. Okay, so a terminating decimal, to terminate means to stop or end, right? So a terminating decimal is a decimal that just stops. It's exact. 1/2 is 0.5 exactly. Stop. Okay, let's take another fraction. What about 1/3? That's a rational number because it's a fraction. What is 1/3 as a decimal? So if I type that in the calculator, what's it going to tell me? 0.33333. In fact, does it ever stop?
No, it's repeating.
It repeats, right? The 3 just keeps repeating. And so anytime there's a pattern that repeats in a decimal, we call that a repeating decimal. So those are the only 2 things that can happen with rational numbers. If I write them as decimals, they're either going to repeat or terminate. That's it. So then irrational numbers are all the other ones, right? Every real number that's not rational is irrational. So what's going to happen if I write an irrational number as a decimal? Then it has to do the other stuff. What's the only other option? If a decimal, if rational numbers as decimals always repeat or terminate, what's that tell you about irrational numbers written as decimals? What do you think? What are they going to look like? Do they repeat? They don't, because if they repeated, they would be rational, right? Do they terminate? No, because if they did, they'd be rational. They're not, they're irrational. So irrational numbers are all the decimals that never repeat and never terminate. They just go on forever randomly. What's an example of one like that?
Pi.
Pi, yeah, pi goes on forever, never stops, but it has no pattern, okay? All right, so one last thing we wanted to add. Irrational numbers, they never repeat, never terminate. Rational numbers always either repeat or terminate. We write them as decimals. So all this stuff will be up there. It's in the notes. I'll put this on Google Classroom today. It'll be available to you. So here's a way to represent all this. Good way to think about it. So if this big rectangle, multicolored rectangle, represents the set of all possible real numbers, we can break that up into parts, two separate parts. The green part will say represents all of the rational numbers, and the red part represents all of the irrational numbers. Can't be both, one or the other. Irrational numbers would be things like pi, or any square root that doesn't simplify, where I'm stuck with a number under the radical. Those are always going to be irrational. Rational numbers would be any number that can be written as a fraction. So for like 2/3 would work, right? Or any repeating decimal. What does that mean, by the way? If you see something like that, 3.153, where the 153 has a bar over the top, what does that mean?
The 153 is repeating 3.153.
Okay, so the 153 keeps repeating forever and ever. So that's a repeating decimal. So that's rational, right? Stuff like that. Okay, inside, question?
I may use this.
Yeah, you bet. Just leave your phone and take a pass. Okay, so inside the set of rational numbers, there's a subset. That big blue bubble would be the set of all fractions with denominator 1. So that's all the integers, right? -11, 0, +13, stuff like that. All those would fit in the set of integers. Inside those is the smaller set of whole numbers, which would just start at 0 and count upward. And then inside that would be an even smaller set, natural numbers, that start at 1 and just count upwards by 1. Okay, there's a way to think about it. Good way to think about it. That's the preferred way. In fact, I'll try to get one of these. Maybe I'll get a poster like this, and just so you can always refer to it to remind you about this stuff. There's another way. I'll just leave this in the notes. I don't really want to spend time on it. You'll see it in the notes if you want to take a peek at this. Just another way of kind of organizing the sets of numbers. But that's probably the best way anyway. That's the way we'll focus on. Okay, so now down to just some practical matters on the homework. What are some things you can do to get answers, right? So what about these? If they want us to identify, first of all, are these rational or irrational? Actually, they're telling us they're rational. And they are, because they're all fractions, right? How would you get the answers if you want to write those as decimals? Don't overcomplicate this. What would you do, practically speaking, on your homework to get those answers?
Put them into a calculator.
Put them in a calculator. That's it. That's all you have to do, is just type these answers into a calculator. And it's going to give you, that's the job of a calculator, is to give you a decimal answer. Okay, that's it. Sometimes you got to go quite a ways before you see what the repeating part of the pattern is. But I knew that had to be either repeating or terminating because it's a fraction. I got to go clear out 1, 2, 3, 4, 5, 6 places. That's how many digits are in the repeating part, though. So I got to keep going out there quite a ways to see the part that keeps repeating over and over again. Okay. What about? Okay, you tell me real quick. We're just going to vote with our thumbs here. Thumbs up is rational, thumbs down is irrational. What do you think about A?
Rational.
Okay, I'm starting to see a trend here. I'm seeing some thumbs up. I like that. I agree. It looks like a square root, though. How do I know that's rational?
It's divisible by
Didn't we say like square root of 2 or square root of 3 is irrational? What's special about that square root, though, that makes it rational?
because it has a whole number of a.
Oh, okay, so I can simplify that, can't I? What is the square root of 25?
5.
5. Okay, so we could just replace that with a 5, which is rational. Rational or irrational? Thumbs up or down. Rational or irrational? 33/9. don't make this harder than it is. What's our definition of a rational number? Any number that can be written as a fraction. Well, that's a fraction. So is it rational? Yeah, it's a fraction, right? How about C? Rational or irrational? That's irrational, because this time I've got a square root that I can't get rid of, right? Square root of 11, you're stuck with it. Nothing I can do. So therefore, that one would be a decimal that just goes forever randomly. Now I'm going to try to trick you. How about the bottom one? That decimal. It's rational if it terminates, which it doesn't do, right? Or it repeats. We see a repeating pattern there? Kind of wants to trick you into saying there is one, but there's not, is there? The pattern keeps changing and never repeats. So that one is irrational. Okay. It's not terminating and it never repeats. All right, here's another game you'll play on the homework. You got to pick all the sets that this number fits into. Okay, 0. 0 is a weird one. We got to figure out, where does 0 go? Is 0 rational? I'm seeing some people nodding their heads. You're right, it is. How come though? Prove it to me. What if you had to tell somebody, like one of your younger cousins or siblings or something who hasn't taken this much math, if you had to justify to them why 0 is rational, how could you do that? A bunch of ways you could probably convince them. Let's name a few. What is
There's
it?
no decimal for like not repeat.
Okay, so it doesn't, as a decimal, 0 is just 0. It terminates. That's a good answer. What else? What do you think?
So it can be put over any fraction, it's just 0.
Okay, yeah, what's 0 divided by 7?
0.
What's 0 divided by a trillion?
0.
What's 0 divided by 1?
0.
Okay, good. So I can divide 0 by any denominator. Can I divide it by 0?
No, you can't
No.
divide by 0.
I got a rule, I can't divide by 0, right? So I can't do that, but if I divide by any other number, I can write it as a fraction, so it must be rational. Any other arguments? Are there any small sets, any subsets of rational numbers, sets that are inside the set of rational numbers that we absolutely know 0 is a part of?
It's a whole number.
Yeah, 0 is a whole number, right? Isn't a whole number part of it's a subset of rationals? Right?
Yeah.
So if 0 is whole, then it must also be an integer, right? That'd be like saying if your pet is a cat, then your pet is an animal, because all cats are animals, right? Okay, good. How about, let's skip down. How about that one? This guy. Take a second and think about that. What are the only sets that that one would be in? Thumbs up or down. Is it a real number? I'll give you a hint. It's always yes, because every number we've ever dealt with is a real number, right? So that one's always going to be true. Is it rational? Thumbs up or down?
Yeah. It's a
It is.
fraction.
How come we know it's rational?
It's a fraction.
It's a fraction, you bet. How about the other two? Well, it can't be irrational. Is it an integer? What do you think? Is it an integer? If it's an integer, that would mean that when I simplify, when I reduce the fraction, the denominator is 1, is it? It's not. So it's not an integer. Okay, good. How about this guy? 2.11. What can you tell me about that decimal? What kind of decimal is that one?
Well, it ends.
Okay, it terminates, right? If it didn't terminate, it would have to look different. If it didn't terminate, like what does this mean? If I put that dot, dot, dot at the end, what does that mean?
That one goes on forever.
That one goes on forever. Does it repeat?
No.
No, because there's no bar up there, right? So when I see a dot, dot, dot at the end, that means it goes forever, no pattern. So that would be irrational, but this one terminates. So it must be rational, right? It is rational, and it's also real. Is it an integer? Well, no, right? Not an integer because it's got decimal places after the decimal point, right? So it's not a hash mark on the number line. Okay. think we're about done. Oh, it's one more. Let's do this one. Then I'll let you work. So list all elements here of this set that are also elements of the set of integers. Let's just cross out the ones that don't work. You tell me which, is 5 an integer?
Yes.
That one's good. Is 0 an integer?
Yes.
Everybody, give me, everybody vote. Thumbs up, yes, thumbs down, no. It is, yeah, absolutely. How about square root of 3, everybody?
Nope.
No good. Square root of 64?
Yes.
Yes, because it's equal to 8. So that one's okay, right? 3/4?
Nope.
Nope, because I've got that 4 in the denominator. Negative 130.
Yeah.
Yeah, okay, it works. So those would be the answers. Oh, come on. There they are. Okay? Good enough. All right, I am going to shut up. You guys can work on the assignment. Bust out your Chromebooks. I'm available to get questions answered.